Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 8th video from the media examination, which was written in the province of Gauteng in the year of 2024. Please do expect a total number of 9 videos since the question paper had 10 questions in total. That simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your media exam, your preliminary exam, and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as well. And please guys, do help us grow the channel by just subscribing. Okay, we are told that point A and B are 0.4 meters apart as shown below. The sketch is not drawn to scale, and then sphere X lies 0.1 meters from point A. Sphere X has 1,238 electrons removed from the surface. Okay, whenever guys you remove electrons from a sphere, you are trying to make that sphere to be positively charged. All together, but whenever you add electrons into a sphere, that means you are trying to make that particular sphere to be negatively charged. So by them removing this amount of electrons, they are trying to make this particular sphere to be positively charged. Okay, and then now we are being asked, what is the nature of the charge on sphere X? The nature of the charge on sphere X is just positive. Why? Because electrons were removed from the sphere. Né? Okay, and then now they want us to calculate the magnitude of the charge on sphere X. The magnitude of the charge, we'll simply say the number of electrons that were removed is just equal to the change in charge all over the unit charge of an electron. The number of electrons that were removed, I simply have 1,238 electrons. I just want to know the final charge. If guys we were not given the initial charge, please always assume that the initial charge was just 0 coulombs. Are you together? And then since guys we are removing electrons, that means the 1.6 times 10 to the power negative 19 has to be positive. Are you together? So for me to find the final charge, I just need to cross multiply over here. So I'll simply say 1238 multiplied by 1.6 times 10 to the power of negative 19. 1.6 times 10 to the power of negative 19. So the charge is just positive 1.98 times 10 to the power negative 16 coulombs. So this is the magnitude of charge of charge X. So the charge there is just 1.98 times 10 to the power of negative 16 coulombs. Okay, and then now they want us to define the term electric field. They want us to define the term electric field. Electric field, guys, is just a region or a space whereby a point charge can experience an electrostatic force. It's a region or a space whereby a point charge can experience an electrostatic force. Now they want us to draw a net electric field pattern for two identical spheres with opposite charges. Okay, that thing will just be like this. I'll have positive charge and negative charge. Since the two charges, guys, are identical, it simply means that the field lines needs to be the same in length, and they have to be equal as well. They have to be equal as well. Okay, 5, 1, 2, 3, 4, 5. Electrons, guys, are always moved from the positive charge to the negative charge. Né? So on the positive charge, the arrows are pointing out of the charge, but on the negative, the arrows are pointing towards that sphere. So this is how, guys, an electric field pattern of two charges with whereby the other one is positive and the other one is negative. There will be an attraction force over there between the two charges. Now, Okay, and then now we are told that at what point, or rather, okay, at what point A or B is the magnitude of the electric field due to charge sphere X is greater? Explain your answer. Okay, if I calculate the electric field at point A due to this charge over here, I'll simplify an electric field at A that is greater than the electric field at point B. Are you together? Why? Because, guys, our electric field is inversely proportional to the distance between the two charges. Are you together? So the distance between A and X is small. So if the distance is small, it simply means the electric field experienced at a point should be greater. Are you together? So now to answer this question, at which point A or B is the magnitude of electric field due to charge sphere X greater? It will be greater at point A. Why? Because there is a smaller distance between the two. Are you together? There's a smaller distance between the two. Remember that, guys. The distance is inversely proportional to the magnitude of the product of the charges. And please, we are explaining this, guys, due to Coulomb's law. If ever you want to, but you don't have to. I know that according to Coulomb's law, the distance apart from the two charges is inversely proportional to the electric force between the two charges. So with this, if this guy over here is small, that means the electrostatic force between the two charges will be, or between the 2 point charges will be high. Are you together? And I know that electrostatic force is equal to I know that electric field is equal to the electrostatic force divided by the point charge. So it simply means that electric field is directly proportional to the force. By decreasing the distance, you are increasing the force. If you increase the force, you are also increasing the electric field at a point. Are you together? So the one with the shorter distance, guys, will have a greater electric field. Okay, now we are being asked, calculate the electric field of sphere X at point B if sphere X is replaced with the charge of -2 nanocoulombs. -2 nanocoulombs. Okay, the new charge on B, guys, is just -2 nanocoulombs. B is replaced with the charge of -2 nanocoulombs. I know that the electric field is basically equal to Q1 all over R squared. K, guys, is just a Coulomb's constant. It's given there by the constants table. It's 9 times 10 to the power 9. The amount of charge, we are told that it's -2 nanocoulombs. Whenever, guys, you are calculating your electric field or your electrostatic force, do not worry about substituting the polarity of your charges. It does not matter. Okay, the distance between the sphere X and B, this is the distance over here. So since this is 0.01, that means I must have 0.03 over there, because 0.03 plus 0.01 must give me this entire distance of 0.04. So my distance over there is just 0.03 all squared. So the electric field is just 9 times 10 to the power 9 multiplied by 2 times 10 to the power of -9 all over 0.03 all squared. This will just give me 20,000 newtons per coulomb. That's just 20,000 newtons per coulomb. Okay, and then now you're told that a negative point charge Y of charge -2.8 nanocoulombs is now placed at B. So at B, we now have charge Y, which is just -2.8 times 10 to the power of negative 9 coulombs. And then we are told that a point charge Z is now placed at point A. Now we have Z over there, and the amount of charge is just positive 3.2 times 10 to the power negative 9 coulombs. Remember that, guys, over there we had X, which was just negative 2 times 10 to the power negative 9 coulombs. The distances are still the same. I just have 0.01 meters over there, and then over there I simply have 0.03. I simply have 0.03. Okay, first question, they want us to draw a vector diagram showing the direction of the forces on charge X because of charges Y and Z. Okay, I want to know how is charge X going to behave as a result of charge Z. Okay, let me use a different color. Okay, this free body diagram will represent charge X. The behavior of charge X as a result of charge Z, since these two guys have different polarity, the other one is positive and the other one is negative, there will be an attraction force between the two charges. Are you together? So the two charges will just pull each other will just pull each other towards each other. Okay, so but my main focus, guys, is on charge X. Are you together? I want to know how is charge X going to behave as a result of charge Z. Charge X will be pulled towards the left by charge Z. Are you together? So this is the electrostatic force between charges X and Z. Okay, now let me see how is X going to behave as a result of charge Y. Both of these charges, guys, are negative, so they will repel one another, but I'm only focusing on charge X. Charge X will be repelled by charge Y towards the left. The two charges will just push one another away. So this will just be the charge between the force rather between charges X and Y. So that simply means that the net electrostatic force is also towards the left. Okay, and then now they want us to calculate the net electrostatic force on sphere X because of charges Y and Z. It's quite simple, guys. Since these are moving in the same direction, that means I'll just take the direction towards the west as positive. So that means F net is basically equal to the electrostatic force between X and Z plus the electrostatic force between X and Y. This is just K Q1 Q2 over R squared plus K Q1 Q2 over R squared as well. That's just 9 times 10 to the power 9. I have 3.2 on charge Z times 10 to the power of negative 9. And then that's 2 times 10 to the power of negative 9 on charge X. The distance between X and Z, guys, is just 0.1 meters. 0.01 meters plus the electrostatic force between charges X and Y. It's still K Q1 Q2, right? 9 times 10 to the power 9 multiplied by the charge on sphere Y. That's 2.8 times 10 to the power of negative 9. And the charge on sphere X, that's 2 rather, times 10 to the power of negative 9 divided by 0.03 all squared. So this will just give me my resultant force. I simply have 9 times 10 to the power 9 multiplied by 3.2 times 10 to the power of negative 9 multiplied by 2 times 10 to the power of negative 9. This is all divided by 0.01 squared plus 9 times 10 to the power 9 9 times 10 to the power 9 multiplied by 2.8 times 10 to the power of negative 9 multiplied by 2 times 10 to the power of negative 9. This entire thing is just divided by 0.03 squared. So our answer, guys, is just 0.000632. This can be written in scientific notation is just 6.32 times 10 to the power of negative 4 newtons towards the west. Remember that, guys, force is a vector quantity, right? So you must give both magnitude and direction. So that's how, guys, we're supposed to tackle that question over there. So please do stay tuned and wait for more videos. Thank you.